Okay, there we go. All right, guys. Good afternoon. I am Kevin Smith. I am going to be presenting today an extension to our discussion last webinar on MQTT. It's a deeper dive showing local and remote brokers. So our agenda will be to, well, I'm going to intro the ELPRO, the deployments, but then go into the product portfolio that communicates MQTT within the IIoT architecture, where we have hardware in the fog and the edge. I'm going to review the MQTT broker definition, and then I'm going to show 3 different demos, one with actually licensed frequency radios, which is the 415U2 within the demo set. Second one would be our cellular IoT gateway, the 641M, with the local IO. And a third one that we have a product that communicates a protocol called Alert 2, and it streams the MQTT directly to the broker. And then I'm going to summarize everything. So for ELPRO, we've been in business over 35 years. I think this year's the 40th year. We provide innovative wireless solutions from unlicensed to licensed to cellular products. And we have over 500,000 products units out globally. So as Matt mentioned, he's out of Tampa. He's the sales director for the Americas. I'm the support engineer and sales engineer for the Americas. So for deployments, we get into water, wastewater. I'm going to go over that flood alert monitoring system, which is right here. We get into power. We also get into, as I alluded to with the 641M and a 645, cellular communications from tanks or from individual tanks. And then we get into the oil and gas because our product is Class 1 Div 2. So as a review, the IIoT architecture has a different sections. So you have the OT, the operation technology section, where you have PLCs, sensors, communications, and a lot of people are wanting that to push up to the cloud, which is the IT section, which is information technology. In between there, the hardware is where we have a lot of different options within what they call the fog, which keeps you in that OT or on-premise area. And then on the edge, we're able to pass this data up to the cloud via a cellular connection. So these are the 2 areas that we have hardware. For the demo or demos today, I'm going to go over a demo set between licensed radios, the 415s, and then I'm going to show one that is going to be communicating to a local broker. The second one will be the edge, so we're using the 641 via cellular connection through to a broker up in the cloud. And then third one is a special one with that Alert 2 that I'm going to show communicating to a local broker. So just in summary, a broker is a very lightweight server that actually will take in published information and then allow other clients to subscribe to that information. So publish, you write the information to it, and then subscribe, read it. So what I'm going to show is our radios are going to be writing the information to a local broker in this area, and then also to one on the cloud. And then I'm going to show VT SCADA and Ignition be able to act as clients to read the information to display it. So the advantages of MQTT, as I mentioned in the last webinar, is report on exception. So it's a very efficient communication protocol that only is communicating or has an option to just look at when the information changes. So to keep the data integrity and make sure you don't have stale data, it sends a birth certificate. So it sends all its information, and then it uses what is called a keep alive ping to keep it alive to where you know you have a connection between nodes. And then if it ever does have a break in communications, it sends what is called a death certificate. So within the configuration, you'll see a keep alive option. And what that is a ping up to 600 seconds that allows the nodes to know that each one is there and that the data is not stale and that it's actually refreshed. The other one, another feature is the unified namespace space. At the end, the demo 3, I'm going to show you data that is coming from the unit, the 115E, to the local broker and be able to show the data in a more structured way. So for the MQTT standard or plain, as I mentioned in the last webinar, this protocol allows, well, it has the different integrators can change or present the data in different ways. With the Sparkplug B, it's more on a standard, and I'm going to show you that in demo 3. So the hardware, as I mentioned, the 115 is going to be used within the demo 3. 415, I have that as a data set for demo 1. But within a data set, we can change it from a Wi-Fi 215 or the new non-25, which is the unlicensed frequency 900. And then the 415 I'm using within the demo 3 that is a special version that uses alert 2. In demo 2, I'm going to be using the 641M as our cellular modem. So at this point, if anybody has any questions throughout, just voice it and I'll answer. But what I'm doing here for demo 1, if you have a demo set, these are pictures of the actual ones I'm using right now. So right here is the 415 U2 connected to the HMI, but then it's communicating to the remote node, which is the picture at the bottom here. And I'm using, and it's shown right here, Teltonica has a radio that actually has the allows you to have a local broker on it. In the future, we're going to build that into our product too. So I'm communicating from the HMI radio to the local broker, and then from a client, which I'm going to show BT SCADA, to be able to show the data. So here's the demo kits. So we have some part numbers if y'all are interested or if you already have them. We updated them with the new communications and the new firmware, which is 2.52 that has the MQTT built into it. And this is what I'm using to communicate back and forth for demo 1. Here's just showing the electrical schematic where I am monitoring the start-stop. I'm monitoring the run light and the comms healthy. I'm also monitoring the supply voltage and battery voltage. And this is just a schematic of the remote. So within the actual configuration of MQTT, there's 5 steps you have to go through. So I did some screenshots and then I'm going to show it live. So within the MQTT, within the software, the cconfig software, you would select it and then it has these 5 different options right here to configure. So first of all, you need to configure your devices. So what I did, and I'll show you, this is just an older config file. I'll show you online what it looks like for the demo. The broker here, I have 2 brokers set up, the local and then one in the cloud. Then you have to map your IO to those devices, and that's where you do it within this tab right here. Also for outputs, you would map the devices to the true IO within this section. And for security, for TLS security, this is where you would select your certificate within the product to talk to the certificate that would be on the broker and give you TLS security. So now I'm going to go into the actual programming software and show the actual configuration. So within the devices, I mapped over the start-stop switch, the running, the comm light, the battery voltage, the supply, and then also the RSSI. Here's where I have the broker. So this is the broker that is within the Teltonica device, which I'll show you that in a second. So within here, I have the IP address, and it has a username and password. If I wanted the TLS security, I would select this, but then I would have to create a certificate and upload it to it. Same thing as I mentioned before for the radio, you would do that in the security tab. So for the inputs, I'm using that device name that I configured within this tab, and then I'm actually mapping the registers that are within the HMI radio. And I'm doing the same for the outputs. For security, this is what I was referring to, that you have to have the certificate and you would have to choose it and upload to it. And what that does is, like I showed you on the broker, and right here, it will create a encrypted communication between devices. So to view this data within a client, which I'm using VT-SCADA to do this, I have my demo set right here, and here's my devices, and it's monitoring the battery to be at 14 volts. I'm communicating between the radios because the communication light is on. And the start stop, I'm going to change that state right now. And it changed the state from off to on. And then the supply voltage for the unit is at 24 volts. So if you go back to this area right here, these are all the tags that I was just looking at within the client that I am browsing the local broker to display that information. So I'm sending it from the radio. Right here to the broker, and then in VT-SCADA, I'm a client and I'm subscribing to it to show the values. Does anybody have any questions on that? So if not, I'll go to the next demo. Demo 2 is I have it wired up right here, communicating. It's the 641M. And what I did is, we have this posted on our website, a configuration for Sparkplug B. So I followed that, and I'm going to show you that within the actual radio. And what I'm going to do is I'm going to produce or publish the switch, changing the state of this switch that's on the front of the unit, which is this cable right here. It's going to send it to the cloud up in the MQTT broker up in the cloud, and then I'm going to connect to it and be able to show you that value change within VT SCADA that I'm running on my computer, and then also ignition. So this is the configuration, the web server within the 641M. And if you notice right here, I'm connected via a static IP SIM card, and I believe it's connected via T-Mobile, because I have a SIM card that selects the carrier that has the strongest signal. And right here within the application, the Sparkplug D configuration is within here. So if you go to the actual manual that I referenced, it goes through this word for word. So if you wanted to set this up on your router, you can.
We do have a question.
Yes.
Can inputs be Modbus registers?
Who puts the Modbus registers on what device? On the 641M?
That would be my
It doesn't use, well,
question.
this right here, well, I'll show you in a second. If you're talking about the cellular modem, they have two ways you can do it. They have I/O that is built into the front of the unit, which the document goes through, and then in the back part of the document, it gives you an example of Modbus. So for the I/O, you would go through here, select it, configure it, just the same process as I did for the 415, the demo set, to where you set up the devices, and then you go in and actually assign the inputs and outputs that's on the front of the unit. So that's for the digital input and outputs on the unit itself. But if you're talking Modbus, you would go within this area right here and actually set up a Modbus slave, where the radio is a Modbus master that's going to poll it. I don't have this working right now, but I had it to where I was polling that alert 2 system, and it can communicate over Modbus through the 115E2. And I had the slave, I gave it the name alert 2. The slave ID was 1, and then I configured all of my registers below it by selecting the plus sign right here, and then you need to know what you're communicating and what the register is, what is the data type, and you just fill it out within there. And then what it does within it, because this radio is an IoT gateway, it has the Modbus master built into it. It'll pull the slave nodes and put it in registers for you, and actually the actual tag names. Once you do that and you have it within this list, that data is being passed over from Modbus to Sparkplug D. And it can be done via data change, which is what I refer to as a advantage of MQTT. It's just going to send the data when it changes, or you can set it up on an update, which is cyclical. So let me show you this. I have it to where it's just working on the IO, but it does work with Modbus slaves to where you can connect to it. And as I showed you here, you would select that, you select the slave ID, and then just fill out and add your addresses or registers below that. So did I answer?
Well, you did get additional information regarding question. Can on the 215, 415, or 925, can the MQTT inputs be Modbus registers or just onboard IO?
No, it could be both. So within the router I just showed you, you can do it IO or via Modbus. But if you're referring to the actual 215 or 415, you can come over here, and in the MQTT section, you create the device, which is really your tag name that you're going to see in the MQTT client that's being passed through the broker. But you can here select from your local IO that is on the front of the radio, or actually serial modules, the 115S, 11, 12, or 13.
Right.
And then in the general purpose is where you would do your Modbus. So when you get to the IO, you can add that and then browse. Well, I don't have it right here, but you would browse that device that you set up over here. And if it's set up as general purpose, that is Modbus registers. And when you come over here and you have the device set up, it allows you to select that device that is Modbus, and then it gives you within the configuration. So I'll set one up for y'all so you can see it.
Kevin, you got a excellent answer response. So well done, sir.
Okay. So within a Modbus node, you have registers, and then here's where you would pick your register. And because it's built into the software, it allows you to select it from there. It's a little bit harder because you can do it through the web server, but the software allows you to do it a little bit more because it's organized based off of the input that you have put in there. You can actually do this from the remote too, but because I have it as the base radio right here, I would think that's what you would want because all the remotes are communicating to the base, and then you can set up your MQTT communications to a local broker or a remote one. So any other questions? All right, so I'm going to continue here. So the demo 2, to refresh, I have a switch that is wired up to the IO in the front. I configured that based off of this manual, and here's the actual unit. I just took a picture of this about 30 minutes ago. So I'm connected via a cellular connection, a static IP SIM card. It detects the strongest signal. So I'm T-Mobile's strongest from my home office. And here's my remote broker that is up in the cloud. So what I'm going to do is I'm going to publish this change of state to the broker up in the cloud, and then I'm going to run VT SCADA or ignition as a client to look at that data. So going back, I'm online right now. I'm connected via this IP address to the cloud, to the cellular network. I followed that document for the digital inputs and outputs, and notice the group, it's Sparkplug B devices. I have it set up as change of state, and this is actually a broker that is in the cloud. And notice it's 1883. It does not have security. If I have 8883, then it uses the certificate. So within the 641M modem, here's where you would bring the certificate and then match it to the one that is in the cloud, the broker that's in the cloud. And then once you do that, it allows it to have a encrypted communication path via TLS. So if I go to VT SCADA, and by the way, VT SCADA and Ignition, they're software companies, and they're the only ones that I know of that has Sparkplug B built into it. They have others like Schneider may have it, but not every HMI communicates Sparkplug B. So if you come over here, I have it to where the remote broker, and notice the name, Sparkplug B devices. I did not fill out the, let's see. I did not fill out the node ID. So you can put that, but what I do is I like to put, let it, and it shows you right here, it uses the serial number if you don't put anything for the node ID. So when you come over here to VT SCADA, it is putting the serial number of the device in place of that. As I mentioned before, this is my Modbus that I set up before, but I'm not using it this time. But here's my digital inputs. So this is based off of that document. You could do this yourself and key this all in, and then have a client, which would be an HMI that's communicating Sparkplug B, MQTT Sparkplug B, and be able to do the same thing. So I'm going to change the state of DI2. And it just changed the state. So it went through, I changed the state of the switch. It's in a closed position. It sent it to the broker. I'm running VT SCADA on my computer. It's a client going to the broker, and it's showing it's changed the state. You could do that too within Ignition. So this is Ignition. So I'm coming over here, and notice it has a checkbox. I'm going to change it back to the off state. And it changed the state. So what I have is I'm actually running a version of Ignition and VT SCADA in their demo mode to show this. So any questions on that? Now I'll provide this presentation. I'm going to have it up on the web to where you can look at it again. But this right here is actually on our website, this document. And that's for the 641M. For the first demo, I'm going to be writing a document that will show the MQTT to be added to the demo set program. So this is the last demo. And what this is a protocol called Alert2 that we have that we use for flood monitoring. We have a big installation in Australia, and what it does is across the country allow you to read data from pretty much a weather station to show you water level, a rain gauge. It can actually monitor the voltage, because these units right here are low power and it runs off a battery or a solar panel. So you can monitor if you have direct power, the direct power, or the battery power voltage. And what it does is it sends this information to a receiver. And what's amazing is you can have 65,000 of these nodes out in the field. You set it up to where it could just send that data once a day if you wanted to, and conserve the power built into it. It goes to a receiver. You can set up repeaters to get the information to the receiver. And then what I'm doing is I'm connecting via a serial connection, which is it's actually using Modbus RTU to bring it into a 115E2. And what the 115E2 is, it's a Condor line that doesn't have wireless. It only has Ethernet, hardwired Ethernet. So I'm connecting that to an Ethernet switch, which is also connected to my computer. And this local broker is that Teltonica device. So I have it actually connected through a switch, all three of these devices. So to do this, because this is the latest firmware for the 115, you can only do it through the web server. So I'm going to connect to it. Here's my IP address, and here's my gateway for that Alert 2. By the way, at the end of the year, I'm going to do a webinar on the Alert 2 product, and it's used by NOAA, a lot of different government agencies to monitor level around the country, or actually around the world. But you can use it in other applications to where you can, but it's only read-only data, so just monitoring. So what I did is, what you have to do is that communications between that receiver and the gateway is RS-485. So it's Modbus RTU. And what I'm doing here is we have special programming protocol of that Alert 2 that passes over that connection at 9600 baud. Here's your configuration for it. It's bringing the Alert 2 information in. The address is 1000. I'm looking at the information every 10 seconds, but this can be up to, I think, 10,800. Here's where it's a little unique, and we programmed this to where we can stream the data across the whole Alert 2 system and converts it directly into a MQTT tag. So what I'm going to show you is within VT SCADA, because I'm talking to a local broker, which is within this area right here, the Alert 2. Here's my 1152E, and they call it a decoder for Alert 2. And notice, here's my station 1000, and here's my sensors. So what I wanted to show you on the diagnostics, this will show you the actual data being streamed. So here's the data right here. And as I described in one of my slides, this is where it sends all the data. So it's your birth certificate. At the very beginning, it sent all of the data. And then it's just reading in the sensors that are connected to the remotes. So what I'm going to do is I'm going to change this setting right here, which I'm bringing in a pulse like if it was a rain gauge. And I pressed it 2 times. So look, it advanced 308, 307, and 308 right here. And notice this right here is MQTT, but the raw data. So notice how the structure is. It has this structure right here, which is different than if you would have done it with just plain MQTT. So this is the Sparkplug B standard right here. And this is where, because you're using Sparkplug B, you have that advantage, but then also it compresses the data 3 times, and you can save data rate on your cellular connection via that, because it's a much more efficient network compared to example Modbus. So if we go back to the presentation, I'm gathering the data, it goes into the receiver. This is the 115E2, that is the decoder. And then I'm communicating Ethernet to that broker, local broker, and I'm viewing it via that VT SCADA. And then within here, we have that diagnostics that I was just mentioning. So if you go look at what I was showing you earlier for one of the features within MQTT, notice the topic right here is more structured than if you had the standard. If you have multiple engineering or system integrators working on a project, unless you give it a standard format, could be different between each one of the system integrators. But one of the features that Sparkplug B does is it gives you a standard way of looking at the data per device. Okay, so does anybody have any questions on any of that?
No additional questions have come in at the moment, Kevin, so we'll give it a couple minutes to see if anyone has any.
Yes, so the way I structured this for demos, this can be replicated to where you could do it yourself. So for example, the demo 1, if you have this demo, I'm going to modify I'm going to add the MQTT portion to the configuration file, and then you can be able to use this information as long as you have a broker to interface to. Same thing for the demo 2. I based it off of the document on the website. Word for word is how I set up the digital inputs. On the back end, they do mention how to configure Modbus. But for me, I set up the Modbus in a special way for the alert 2. And that's what was programmed in my unit. And then the demo 3 is a newer product, newer firmware for the 115E2. So you'll see more documents coming out that will show this. So if anybody has an application that requires read only of different sensors, because it could be any sensor, we have a solution, and it's called Alert 2.
We do have a question, Kevin. What was the cost of the local broker that you're using?
Well, right now, the one that not everybody has it. So the one that I had, because I had it for testing for a
Mhm.
project in the past, is Teltonica. But the problem they have is they only have it to where it is compliant with Sparkplug B 3.0. And we're up to 5.0 now with MQTT Sparkplug B. There's other products like Wadmuller has one that I'm about to test, and then Opto 22 on their Epic or the RIO has it to where you can run it on it. And the reason why those can run it, it can run on Linux. So if you have like a Mosquito broker, you can run it on those devices. In the future, right now, we have within our existing Condor line, we're limited to memory. So what I'm trying to do is get them to add that into our product to where you don't have to buy a third party product. But in about a year or so, we're going to have a whole new product line that will definitely have it built into it. And it will have a lot of other features built into it.
Yes, and that alludes to a couple of questions that just came in while you were explaining. Any time frame for ELPRO devices becoming brokers? We mentioned within the next 12 months. I know we are diligently putting the wants and needs and what we have real estate for features and functionality resources for the new product line. And then continuing another question regarding.
Well, wait, let me add to that. I've been with the company since the beginning of the year. I put that on the engineering list, and they're trying to put it into the existing memory, but it may not be across the whole line because certain products have more memory. So I'm every Tuesday, like last night, because it's my 4 o'clock Central Time is 7 o'clock Australian time. They have a engineering meeting really at 10 o'clock, so it's 7 o'clock my time, and we go over this. So I'm going to check and see if they have it on the list, but a lot of the resources are going into the new product line called the Quantum. But in the meantime, I'm looking at other products to do this because the thing is, you can put this Mosquito on a computer, but you can easily forget it's on that computer. And then if IT takes control of your computer and then shuts it down for an update, it's going to shut down the network. So what I've done is looked up hardwired units that are DIN rail mounted that are in an enclosure, and some of them, like the Wadmuller one, is and actually the Opto 22 one is Class 1 Div 2. So you can add that Mosquito broker onto those units because it runs Linux.
Okay.
Any other questions?
No, and I believe the questions that we have are going to require follow-up responses as more information comes in.
Okay.
ELPRO device becoming a MQTT broker. More information about that will be a cellular modem, radio, or an independent device. Estimated date of release. So I think we covered all of those as best we could at this time, but definitely there is interest, and we'll pass that information on as soon as we have access to it.
Yeah, and if anybody needs any help setting this up, let me know. And if you have a project that could use this protocol, I believe we're the only company that has it across all of the communication protocols, meaning Ethernet, hardwired, Wi-Fi, unlicensed non-100, licensed 152 non-100, and then also cellular. And then we have this unique guy right here that is a low-powered unit that can communicate right now, licensed non-100, but I'm working with engineering to come out with an unlicensed version. So it would be more of a non-25 U1.
That's all we have for questions at the moment, Kevin.
All right. Well, thank everybody for y'all's time.
Thank you. This will be posted to our YouTube channel shortly. I do have a caveat. I do apologize. We had some technical issues with the last recording. We have to re-record that, so that will be posted here shortly as well. Again, thank you all for your time, and I'll have another invite in about 2 weeks for our next session in the ELPRO webinar series. Thank you. Have a great day, folks.
Thanks.